I want to show 3 different examples of getting random numbers in NumPy. And so I'm going to import NumPy as NP. And then let me show you how I used to do this. So how I used to get a random integer was do NumPy or NP dot random dot randint. But let me show you what the documentation for this looks like. So here, if you look at this note, it says if you're using new code, then instead of this method that I'm showing you, instead you should use a method of a default RNG instance. So that's what we're going to do in this video. So let me start out by making it. I'm going to name the variable RNG. That stands for random number generator. Doesn't stand for range, which is what I originally thought. And then I'll do np.random.default RNG. And I use tab completion there because I couldn't quite remember how to spell it. And then you put parentheses afterwards. And this is some syntax that's going to show up a lot. And this is like saying, make a new random number generator object. And you can think of it sort of like a function. This is like creating a new object. Okay, and now we're going to use this RNG instance. We're going to use that to do all 3 of these types of randomness computations. So to get random numbers, I can do rng.random. And let's check how the documentation looks. So it takes as input size, which should be either an integer or a tuple of integers. And notice that there is no way to specify like the beginning and the ending of the interval you're choosing from. So this is just always going to choose uniformly distributed random real numbers between 0 and 1. If you want to go from 0 to 3, you have to do something else. So here's the first example of how to do this. For example, if I say 10, then that gets me a length 10 NumPy array of uniformly distributed random numbers between 0 and 1. If I do, let me copy and paste this. If I do 10 comma 2, make sure you have it inside these nested parentheses so that Python knows this is supposed to be a tuple. Okay, then I get a 10 row by 2 column array, NumPy array of uniformly distributed random real numbers. What about, let's get uniformly distributed random real numbers between -3 and 4. How can I do that? So I can do RNG, and let's say get 10 of them. So RNG.random 10. So that gets me 10 numbers, but has nothing to do with this between -3 and 4. Well, the width of this interval is 7, so I can get randomly distributed real numbers between 0 and 7 just by multiplying by 7. So like minimum would be 0, maximum possible would be 7. And then if I subtract 3 on the outside, then the low point shifts down to -3, and the high point shifts down to 7 minus 3, so shifts down to 4. Okay, so here are 10 uniformly distributed random real numbers between -3 and 4. And once you understand that syntax, random integers is pretty similar. And it's actually in some ways easier because it includes a chance to say what should be the low point and what should be the high point. So I can say RNG, and now instead of saying random, I say integers. And let's look at the documentation again. So here, the first input is the low point, second input is the high point, and then we say size. So let's try this. RNG.integers. Say I just always want to choose either 0 or 1. So let's try 0 for the low point, 1 for the high point, and say size equals 5. So it looks a little strange that size was always, or that the value is always 0. Let's try it again. Still zeros. So what's going on here? And this is a convention that happens all the time in Python where the right endpoint is not included. So here the low endpoint is included, but the high endpoint is not. So in this example, the 1 is never an option. So if we want to go, say, 0 to 10, and this will never show up as a 10, but it can show up as high as 9. Okay, there's a 9. But no matter how many times we did that, we wouldn't see a 10. Okay, maybe I'll do 50. Okay, no 10s. Random sample, this one's a little bit different. This one, so the name for it is choice. And the first input is supposed to be something that is like an array or like a list. And then it's going to create random choices from within that list. So let's try it. Let's go up here and call this A for array. And then I'll tell it to show the A at the bottom. Okay. And now let's do rng.choice A. So that gives me a random choice from that array A that I made. So like, let's look for 0.612. Does that show up here somewhere? Yes, right at the beginning, I missed it. 0.612. Okay, and then what other options did we have here? We can say size, and we have this replace. So let me say size equals 2 by 3. And all of these numbers here show up somewhere in that original array A. For example, here's negative 2.93. Here's negative 2.93 showing up twice. And notice how that showed up twice. If you don't want that to be possible, then you can say replace equals false. And now every number here is only going to show up at most once. What if I did 20 by 3? Okay, then I get an error because it's trying to take 60 total entries out of this array A, which only had 10 entries in it. So any product here that's strictly bigger than 10 is going to give me this sort of error. And it's good practice to try reading the error. Like, you'll never be able to read this part or this part, I don't think. But this part can be helpful, especially when there are lots of lines in the same cell. And in this case, this line is also helpful because this is saying you're trying to take a larger sample than the population. You're trying to take 60 elements in your sample, but the original population was only 10. Yeah, that's all I'll say in this video. Thank you for watching.